Why we are discussing this artificial neural network in this? Because see, it is the most, you can say, famous algorithm of machine learning that is inspired from the terminology of human brain, that how human brain is perceiving the real world and taking the decision. Okay, so see, these are the a few key things that you have to know about the artificial neural network, a type of representation or the basic term. So neurons are there, activation functions are there, cost function is there, the gradient descent algorithm is used to update the weight, and the entire workflow we can complete in the manner of back propagation. Say this is the diagram of a biological neuron, and in which this neuron is collecting the information from the dendrites, and means from the other neurons, and process it and passes it through the axon, and if it is some meaningful information to the other neurons. Okay, same is modeled in the form of this you can say mathematical representation. These x are our input, okay, and these weights are the same weights of the model that we have discussed, okay, and after multiplying these weight with the input, we are summing up, and one activation function is there just to check whether this information is exceeding some threshold limit or not, and if it is more than that threshold, then we have to give as a output. Okay, so this is the one basic element of the artificial neural network that we can call as a neuron or the perceptron model. So if you can see, it is the you can say familiar type of equation. This B0 is nothing but the bias we have already discussed. Okay, W are the weights and X are the inputs. Okay, so this we have to train from the difference between the deep learning approach and the your traditional machine learning approach. See, in the traditional machine learning approach, input data is there over which we have to do the feature extraction, and then we have to apply any algorithm. While in deep learning, what happens? We have to give the input data directly to the deep learning algorithm, and no feature extraction part is there. Okay, and this we can do with the, see, this is the basic you can say diagram of convolutional neural network. See, input is there, okay, convolutional layer is there, pooling layer is there, okay, and again multiple convolutional layer and pooling layers are there. So in convolutional layer, see, a type of convolution operation we are performing. Say this is your filter or the kernel, and the person though means the participant, those are from the, say, having the idea of the some image processing. So same convolution operation we are performing here. So we will get the new values, or over these new values we have to perform the max pooling. So max pooling is nothing but we are defining a type of mask, and out of these, say, 4 values, we are taking the max value. So see, out of these 4 values, 20 we are taking, out of this 4 value 30 we are taking, and out of this, okay, so see, this I have just discussed this model, okay, of a neural network, and so this first one is the biological representation, and this we are representing as the model. Okay, so X is the input, and this W are the same weights, and a summation we have to do after the multiplication, and this is the activation function part. Okay, so this for activation function part, it is nothing but a simple mathematical function in which we will pass this summation value, and we will get some change or the scaled value. Okay, and this we can simply represent is with this particular equation that we have already discussed, where B is the bias term, then W are the weights, and X are the input values. Okay, in previous we have seen in the simple case of Y is equal to your mx plus c. So your x here are multiple x, means x1, x2, x3, x4. These m are also multiple m's, so wi, w1, w3 like this, and c is simply your this b0. Okay, so see different type of activation function are there: step function, sigmoidal, hyper tangent function, then rectified linear unit function. So see, these are the simple representation with their equation: step function, sigmoidal function, then your hyperbolic tangent function, your rectified linear unit function. Okay, and this is the cost function, or that we are calling as the error. So see, here we are taking the mean square error, n are the number of, you can say, sample over which we are calculating the error, y is the actual output, p is the predicted output, and we are making the square in summation. And this is the gradient based gradient descent approach for okay, so this is the gradient descent approach that we have to use for the training purpose. So here you can see we have to optimize the weight, and this is the learning you can say steps, and with what step or increment we are doing in the your weights. Okay, and this is the same thing that we have discussed, and it is the same that is known as the backpropagation method. So here you can see this X we are applying over the artificial neural network model, and so inside this nothing is there, only weight and bias is there to train to learn. Okay, so we are getting the output as a p predicted value, y we can take from the actual values, we will estimate the error. Okay, and this error is back propagated to update the weights and bias of the model. Okay, so that's why this name is there, back propagation, means this error is propagated back into the model. Okay, so see, whatever we have discussed is just happening in one single neuron. Okay, in a one single neuron, means input, your multiplication, then summation, then your activation function, all these things happen, then you will get the one output, and this entire process is repeated in each of the neurons, so that is called the multiple perceptron network. So see, this is the, you can say, very basic diagram of artificial neural network. In each, we are simply repeating your multiplication with the weight, then summation, then activation, and then we will get the output that is transmitted to the next layer. So multiple layers are there and multiple neurons are there. Okay, so these are the very basic steps of your artificial neural network. Okay, so this we have already discussed, so these simple things I will just skip. These are the generalized delta rule by which we are able to update the our weights. Okay, this model we have already discussed in the starting, that how we will take the data samples in the ratio of say here we are getting the 70%, here we are getting the 30% data for the testing, and internally we are splitting 50% and 20% for training and validation set. Okay, and this is your final train model that we are using for the testing. 112 we are taking, and out of this 37 we are taking. So it is nothing but we are reducing the dimension, and we are just taking the high magnitude values. Okay, so this is the architecture of your CNN. In this, we can say, see this part convolution and max pooling. This is playing the role of feature extraction. Okay, and this fully connected layer is nothing but, you can simply understand that it is the simple artificial neural network, and in which we have to do the training. Okay, so this is the difference between your traditional machine learning model and CNN models. In CNN model, feature extraction part is done by the convolution and pooling layers. Okay, and at the end we have to combine all the extracted feature, and we have to give into the fully connected layers. So see, at the last I will just explore one application area of machine learning in mechanical engineering, and that is very famous area of research. So that is known as your machine health management. Okay, this is called as the machine health management. Okay, so here our aim is to identify the health of the machine based on the vibrations, or you can say the condition of the machine. For this we have to collect the data and observe that data, that vibration are coming from which particular part, or which particular part get damaged. So means before that the machine will break down, we can replace that part. Okay, so that is also known as the your intelligent fault diagnosis. And previously you can say we are doing this fault diagnosis based on the rule based things, but nowadays we are taking the help of machine learning algorithms to diagnose this thing. So it is the new field is known as the intelligent fault diagnosis. If you will search this keyword, so you will get the many papers. Okay, so this is just you can say a research publication graph. So you can see means up to 2010 peoples are applying the SVM, ANN, and a decision tree, random forest type of algorithm in this particular field. And at present you can see the deep learning models, ResNet, okay, and other famous model of the convolutional neural network and the deep learning are used. Okay, and in the future, if you want to do in the research in this particular area, so the concepts of this transfer learning are also used. And transfer learning basically says you have to create one large database and do the training of the model. Okay, and over any database you can switch that training process. Okay, so this is the little bit more advanced topic as compared to the deep learning also, and so it will take little bit time to understand. Okay, so these things already I think we have discussed in detail, the data extraction, data collection, feature extraction, okay, expert system based approaches. Okay, so here see these are just the phases of this, that how we are collecting the data with the help of different sensors from the engine of the any vehicle or the machines. Then how we are extracting the feature, doing the and categorizing the feature into say sensitive and insensitive features, and based on the requirement, and at the last we are doing the classification. Okay, so these are just the, you can say, example of different time domain feature, frequency domain features, and time frequency domain feature. Okay, and at last it is a type of summary. You can see the over which part of the machine we are applying the or attaching the sensor to sense the vibration or the damage. So like over the bearing, gears, motors, engine, and over the other part. So see this data you have collected from the a recent review paper, and overall see simply your neural network approaches are applied for the classification. Okay, so see this paper you may also there, it is a very having very rich content, and if anybody want to explore the this intelligent fault diagnosis field and the machine learning application, so you will please refer these references. The second reference is the having very rich content, that is the applications of machine learning to machine fault diagnosis, a review and a roadmap. Okay, and it is just published in 2020, so all the latest reference you will get in this.